Hello everyone and welcome to our channel MooTechie. We're thrilled to have all you budding engineers, technologists and curious minds with us today as we dive into the foundational world of manufacturing. Get ready for an engaging journey through Introduction to Workshop Technology. Now, let's begin our exploration by looking at the roadmap for this course. We'll be covering 5 key units. Unit 1 is our introduction, focusing on workshop practice, safety, care and precautions. Unit 2 will take us into carpentry, looking at woodworking tools and their uses. Unit 3 delves into the heat treatment process, that's hardening, tempering, annealing and normalizing, and metal work like cutting, soldering, brazing and welding, including electric arc and gas welding. Unit 4 introduces us to smithy and forging operations, their tools and equipment, as well as bench work. The bench itself, flat surface filing, chipping, scrapping, marking out, drilling and screwing. And finally, Unit 5 will give us an introduction to major tool machines like the lathe, milling machine, shaper and planer, drilling and boring machines, grinders, and even CNC machines. It's a packed syllabus, so let's get started. A great starting point is understanding what workshop practice truly entails. Workshop practice is a very vast field, and it is very difficult for anyone to claim a mastery over it. So what does it provide? It gives us the basic working knowledge of the production and properties of different materials used in the industry. It also explains the use of different tools, equipment, machinery and techniques of manufacturing, which ultimately facilitate shaping these materials into various usable forms. In general, various mechanical workshops know by long training how to use workshop tools, machine tools and equipment. This is why it's so important that only trained and competent persons should be admitted to this type of mechanical work and permitted to operate equipment. Moving forward, let's understand the journey of a material. It often starts with ores, which are the raw materials for industry. These ores undergo suitable reducing or refining processes to convert the metal into a molten form. This molten metal is then poured into a mold to give commercial castings called ingots. Finally, through another suitable process, we obtain usable metal products of different shapes and sizes. Now, how do we shape and transform these materials? This brings us to the core processes. We have 1. Primary shaping processes, 2. Machining processes, 3. Joining processes, 4. Surface finishing processes, 5. And finally, processes affecting change in properties. Let's look at each of these a little more closely. First, the primary shaping processes. Now here's an interesting point. Some of these processes finish the product to its usable form, whereas others do not, and require further working to finish the component to the desired shape and size. For example, an operation like wire drawing leads to directly usable articles which do not need further processing before use. Other common primary processes include casting, forging, bending, rolling, drawing, and powder metal forging. Next up, we have machining processes. A large number of components need further processing after primary processes. This is known as a secondary operation to obtain desired shape and dimensional accuracy. These operations require the use of one or more machine tools, various types of cutting tools and cutters, job holding devices, and marking and measuring instruments. So what are these common machining operations? Well, they include turning, threading, drilling, boring, planing, shaping, sawing, milling, grinding, and slotting. Now what if we need to put parts together? That's where joining processes come in. These processes are used for joining metal parts and in general fabrication work. Such a requirement usually occurs when larger lengths of standard sections are required or when several pieces are to be joined together to fabricate a desired structure. The common processes you'll encounter are welding, soldering, brazing, riveting, screwing, and pressing. But a part isn't truly finished until its surface is right. This is where surface finishing processes play a crucial role. Let's be clear, these processes should not be misunderstood as metal removing processes. They are primarily intended to provide a good surface finish or a decorative or protective coating on the metal surface, although a very negligible amount of metal removal or addition may take place. So any appreciable variation in dimensions will not be affected by these processes. The common processes employed for obtaining the desired surface finish are 1. Buffing 2. Polishing 3. Lapping 4. Belt grinding 5. Metal spraying 6. And painting. Finally, we have processes affecting change in properties. This is fascinating because these processes are employed to impart certain specific properties to the metal parts to make them suitable for particular operations. Most physical properties like hardening, softening, and grain refinement call for particular heat treatment. And heat treatments not only affect the physical properties, but in most cases also make a marked change in the internal structure of the metal. So is the case with cold and hot working of metals. So the three key types here are 1. Heat treatment, 2. Cold working, 3. And hot working. Now, with all these powerful processes and machinery involved, safety becomes our number one priority. Let's talk about workshop safety. The concept of safety in workshops has been written not only to provide appropriate safety procedures but also to assist trained personnel. It serves as a reference document outlining the general principles of safe working practices relevant to mechanical engineering, especially in areas where definite safety measures are required. It's important to know that safety is backed by law. Various acts relating to accidents are spelled out in the Workmen's Compensation Act of 1923, the Factories Act of 1948, and the Fatal Accidents Act of 1855. These acts describe the regulations for fencing and guarding dangerous machinery, items, and employers' liabilities. But what exactly is an accident? Well, it is very difficult to give a perfect definition. However, a generally accepted conception is that an accident is a mishap, a disaster that results in some sort of injury to men, machines, or tools and equipment, and in general a loss to the organization. The injury or loss may be of minor or major nature, and the accident is then termed as non-reportable or reportable. For example, a small cut on the body will be a reportable accident in a training workshop, but it can be treated by first aid and may not be considered reportable in a production unit if no significant time is lost. So what causes these accidents? Here's a sobering thought. 98% of accidents could be easily avoided, provided due precautions are taken well in time. A very familiar slogan says it perfectly. Accidents do not just happen. They are caused due to the failure of one element or another. And the most unfortunate factor is that the human element is the most pronounced of all which fails. The common causes which lead to accidents are 1. Unsafe working position. 2. Improper or defective tools or their improper use. 3. And improper acts which result in violation of safety rules and non-observance of safety precautions. Let's look at some common sources of accidents. With a large number of machines in use and an even larger number of parts, we must identify sources of danger that require guarding. Some common sources are projecting nips between sets of revolving parts like gears, rolls, and friction wheels, projecting fasteners on revolving parts, revolving cutting tools like circular saw blades, revolving drums, crushers, spiked cylinders, and armed mixers, revolving shafts, spindles, bars, and tools like drills, reamers, boring bars, and chucks, projecting sharp edges or nips of belt and chain drives like belt pulleys, chains, sprockets, and belt fasteners, reciprocating tools and dies of power presses, drop hammers, and revolving presses, grinding wheels and stones, reciprocating knives and saw blades such as in power hacksaws, revolving drums and cylinders without casing, like concrete mixers, intermittent feed mechanisms, and projecting nips between various links and mechanisms, like cranks, connecting rods, piston rods, and rotating wheels and discs. Thankfully, we have common methods of protection. These are our shields against potential harm. The common methods are 1. Safety by position. 2. Safety by construction. 3. Safety by using interlock guards. 4. Safety by using fixed guards. 5. Safety by using automatic guards. 6. And safety by using distance guards. Let's understand what each of these means. First, safety by construction. When a new machine is designed, it should be ensured that all its dangerous parts are either enclosed in suitable housings or provided with suitable safety guards. Think about the belt drive and motor in a lathe. They are enclosed. Lubricating points are on the outer surfaces, so we don't have to open the interior every time. Next, safety by position. This means the machine is designed so that the dangerous parts are located in such a way that they are always beyond the reach of the operator. The goal is to make them enclosed in the body or housing of the machines. Now let's talk about safety by using interlock guards. This is a very efficient and sound method. The guard cannot be removed and dangerous parts exposed unless the machine is totally stopped. Similarly, the machine cannot be started unless the guard is in position. An interlocking guard can be mechanical, electrical, or a combination. It is essential that it should, first, prevent the starting of the machine if the interlocking device fails. Second, always be in position to guard the dangerous part before the machine can start. And third, remain closed until the dangerous part is completely at rest. Another common method is safety by using fixed guards. These guards are either an integral part of the machine or are tightly secured to it. They have a rigid construction and are placed so that any access to the dangerous parts is totally prevented while the machine is running. Steel sheets are often used because they allow for easy fabrication and are lighter in weight. Sometimes, fixed guards are made adjustable to accommodate different kinds of work, or they are provided at a distance from the danger point. Then we have safety by using distance guards. The principle here is simple. A high fencing is made of bars at a suitable distance from the machine. This ensures that even if the operator extends his hands over it, his fingers or clothes cannot reach the dangerous parts. An additional safety measure is a tripping device to stop the machine quickly in case of an accident. And finally, safety by using automatic guards. The operation of an automatic guard is actuated by some moving part of the machine. It's linked so that it automatically brings the guard into the protecting position before the machine operation starts. The design is brilliant. It automatically forces the operative away from the dangerous area before the operation starts and does not permit access again unless the machine stops. One thing to note, due to the time required for their operation, these guards are not suitable for quick-acting machines. They are favored for heavy and slow-acting machines like heavy power presses. Now let's bring it all together with general and personal health and safety requirements. Personal safety procedures have to do with the way a person is attired for the workshop. The rule is simple: always wear your personal protective equipment, your PPE, and do not wear defective PPE. General safety procedures have to do with the general working environment. Remember to clean up all spills immediately, keep the workshop clean, and ensure all machine guards are in place before use. We also need to understand appropriate health and safety materials and accessories. So what are accessories? Anything that can be added to something else to make it more useful, versatile, or attractive. And safety materials? These are items used to prevent injury or damage to someone or something. Finally, let's clarify some terms. Equipment refers to supplies, items, instruments, tools, or other things needed for completing a specific task. And a tool is a device, equipment, or gadget, especially one held in the hand, that is used to perform a particular task or function. And that brings us to the end of our introduction. We've covered the journey from raw material to finished product, the vital processes in between, and most importantly, how to stay safe while doing it all. This is a fascinating field, and we've only just scratched the surface. To continue your learning, these are the suggested study materials. Thank you for your focus and curiosity. Keep learning, keep building, and stay safe. Thank you. See you in the next class.